Alright, so in this video we're going to be looking at reading dot/line plots. So let's look at the first problem here. It says the Department of Transportation recorded the speeds of cars in a 40-mile-per-hour zone. So if you look over here, here's our line plot with all the dots, or it's our dot plot with all the dots on it on a number line. So and then beside it, we have a table that also records the same data. So here we can see that we have one car was going 36, another car was going 40, 42, 44, 40, 41. So all these numbers here are the different amounts of cars. All we did was take this information from the table and we put it in a graph. This way we can see the information and it's more organized. One thing we really need to remember though is when finding like the lowest speed and the highest speed, we're not necessarily looking at where the number line begins. So 34 is not the lowest speed here because that's not where the data begins. So when we want to find the lowest number, our data starts here at 36. So here we can put data starts at 36. Okay, so that would be our lowest speed. So I'm going to put smallest number in data here. And then same thing with the highest speed. Just because we see 50 on the number line, that's not where the data ends. 50 would not be the highest number. Here we have right in between 46 and 48. 47 represents the car that has the highest speed. So this would be the biggest number in our data. So I'm going to put BG for biggest, and I'm going to put data ends at 47. So our slowest car was going 36 miles per hour, but our fastest car was going 47 miles per hour. So we can go ahead and answer questions 1 and 2 now. Question says, what was the slowest speed recorded? Again, remember, we're not starting at that number line. We're looking for the slowest, which means the smallest speed recorded. So that would be 36, because my very first dot starts at 36. So that one would be 36 miles per hour. Remember, you're looking for where the data actually begins, and that's going to be your slowest. You could also find the data in the table and see that 36 is the smallest number in the table. But remember, all we did was take the information from the table and we organized it into the dot plot. All right, now the next question is asking question number 2. What is the fastest speed recorded? And remember, we're going to have to look at where our data ends. And our data ends at 47. Remember, even though our number line goes to 50, that's not where our data ends. Our last number is here at 47. So our fastest car is going 47 miles per hour. All right, now let's look at number 3. It says how many cars are recorded going 43 miles per hour. So remember all these little dots here, each dot represents a car. So I'm going to write that. Each dot represents a car. And here, I see here's 42 and 44, so 43 must be right in here. If there's 2 dots above the 43, then that must mean that two cars were going 43 miles per hour. That information is also in my table if I were to look there. But again, it's easier to read with a dot plot. So it says how many cars were recorded going 43 miles per hour. And again, we're going to just read how many dots are directly above the 43. Our answer would just be 2 cars. Okay. Our next question is, what was the most common speed recorded? What is this called? Now, most common would be the number that has the most dots. And if we come over here and we look at our data, we can clearly see that the number with the most dots is 40. So most of the cars were going 40 miles per hour. Even if you were to read it from your table, you can see that 40 popped up 5 times. It occurred more frequently than any other miles per hour. So it says, what was the most common speed recorded? That would be 40 miles per hour. And what is this called? Remember, we talked about it before, that the number that occurs most often, remember, we call this the mode. So the most common speed is also known as the mode. Okay. And then let's look at the last one. It says how many car speeds were recorded. Well, remember, each dot represents a car. So you can count up the number of dots. You could even look in the table and count how many speeds you wrote down. But if you count up all the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I count 21 dots. Remember, each dot represents a car, so therefore my answer would be 21 cars. And hopefully that helps you on how to read dot and line plots.